numbers just so we can practice using these properties. You will probably want a calculator in a minute, so grab one if you don't have one. We'll go over the properties and then we will extend them into the uglier things. Okay? So the first thing, y to the fourth times y to the seventh. If you have those y's multiplied together, what do you do with your exponents? All right, so 4 plus 7 gives us 11. All right, the second one, if we have a power to a power, what do we do? So 4 times 7 is 28. Third property, if you have division, what do you do with your exponents? Subtract. Do you have more y's on top or bottom? So it will end on the bottom. So 7 minus 4 is 3. It just goes wherever you have the most of them. And what do I put on the top? Okay. The fourth property. What if you have a negative exponent? So this would become
1 over
y to the positive 3. Okay, the fifth rule. What's anything to the 0 power?
1.
Good. Okay, the sixth one. I'm kind of branching in, slowly getting into more complex stuff. If you have multiple things inside here, okay, it's still one term. There's no addition or subtraction. But I have things multiplied, I have a division. What do I need to do with my square? We have to take it to all of them and multiply it with any exponents that are there. So this is just like a 3 to the first. 1 times 2 just gives me a 3 squared. Y to the 6th over 8 squared. And we can simplify 3 squared is 9. Y to the 6th over 8 squared is 64. Okay, again, we're only allowed to bring that exponent in if it's a single term, so nothing adding or subtracting. All right, the last one. We were doing factoring before our last quiz. When I asked you to factor, what's the first step to factoring always? Greatest common factor. So when I'm looking at these, how do I decide what my greatest common factor is?
The lowest exponent.
Lowest exponent. So that would be y to the 4th. Okay, if you pull it out entirely, when you factor that out, it's like dividing it. What happens if you divide something by itself? 1 minus. Okay, if I'm like dividing this, it means subtracting those exponents. So that's 1 minus 5y to the 3rd. Are there any questions on these properties with the nice integer exponents? So let's extend that to uglier exponents. Okay, number 1. 49 to the negative 3 halves. Let's talk about the negative for a second. What does a negative exponent do to my fraction? Flips the whole thing, so it becomes 144 over 49. Okay, when it was a fraction, we were working on this yesterday too, we write it in radical form. It's like, which one goes on the outside? The denominator. So this is saying the square root of that cubed. Okay, what is the square root of 144? 12. The square root of 49? 7. And I need those to the 3rd power. So you probably don't know 12 to the 3rd off the top of your head. That's fine. And use your calculator. And 7 to the 3rd. Number 2. When I have all of these x's multiply together. What am I going to do with my exponents? Add them. Okay, so kind of talking to some people, they were telling me that they were getting confused with the adding fractions and adding negatives. And if that's the part that you're getting hung up on, what could you do? Use your calculator. Have I told you you have to do that in your head? No. I'm trying to get you to figure out these exponent rules. So if you get confused, you can use your calculator to add those, okay? I'm not going to judge you. So you can just type it all in your calculator. 4/5 plus 2/3 plus -1/2. I do want it written as a fraction at the end. So everybody plug that in to make sure you know how to do that on your calculator. You just do 4/5 plus 2/3 plus -1/2. And remember, if you go to math number 1, you can get your fraction. So this is x to the, you guys get 29/30?
Yep.
Okay. So ugly number, but it's not a big deal. We can use a calculator if we have to. All right, the third one. What do I have to do here? Distribute. So when I multiply, I'm going to multiply my coefficients and I'm going to multiply my a's. So my coefficients, 3 times 5 is 15. When I multiply my a to the 3/4 and my a to the 1/3, what do I do with the exponents? Add them. Again, if that's what confuses you, use your calculator. 3/4 plus 1/3. 13/12. Plus. Okay, 3 times 2 is 6. A, we have 3/4 plus 2/3. 17/12, is that what you said?
Yeah.
Thank you. Is that helping you guys? Yes, ma'am.
When do we know when to multiply the exponents?
If the A is only written one time. So if you have the base, each time you just add them. If it's only once, you multiply. Good question. Anything else? Number 4. All right, so on the top, b squared to the 0. So that is a case where the b is only written once, so I multiply those exponents. And 2 times 0 is 0. What is b to the 0? 1. So a couple options here. You could change the top to a 1. And then what's going to happen with your negative exponent? What does that do? Moves it up. Does the 5 move?
No.
No, 5 has an exponent of 1. It's going to stay. Or you could think of it as if I have b's on top and bottom, what do we do with your exponents? Subtract. 0 is bigger than -6, so 0 minus -6 is +6. Or the same thing as if we just moved that b up to the top. If you wanted to put your 1 in front for the b to the 0, 1 times b to the 6, that's all the same. It's correct. Number 5. So if I start on the top, what do we need to do first? We need to multiply that stuff together somehow. So multiply the like parts. -6 times 3 is -18. X to the 3rd times x. That's like understood to be a 1. And what do we do with those exponents? Add them. So 3 plus 1 is 4. My y's. This is a y to the 1st times y to the 4th. So 1 plus 4 is 5. There's 9. X to the 8th, y to the 3rd. So now if we reduce, negative 18 divided by 9. Okay, do we have more x's on top or bottom? So it ends on the bottom. 8 minus 4 is 4. Will the y's be on top or bottom? Okay, and 5 minus 3 is 2. Just a couple more of these. Number 6 is a lot like this. My coefficients are 5 and 15. So can I reduce that? What does it give me?
1/3.
Okay. X's. What's bigger, negative 2 or negative 4?
Negative 2.
So that's on the bottom, it'll end on the bottom. So you're doing negative 2 minus negative 4. And you get 2. Y's. What's bigger, 8 or negative 3?
8.
So you're doing 8 minus negative 3, which gives you 11. Last one. If I want you to factor this, what did you tell me you pull out when you're factoring?
This one.
So what's smaller, negative 8 or negative 4?
Negative 8.
So I'll take out x to the negative 8. When I factor that out, it's like dividing it. If you divide something by itself, you get 1 minus, okay, if I divide this. So to divide, it's subtracting those exponents, negative 4 minus negative 8. It's positive. All right. Good, bad, so-so. Where are we at with this? Good. Is it better than the first time that we saw it? Getting better? Okay. Any questions over these that we've gone through? So the second part on here is what we've done the past 2 days with the radicals. So those were a little bit easier for us anyway, but I wanted to do some review with that as well. So the first one, what does this negative on the outside do? It just stays there. All right, since this is all one term, we can do each piece. What's the 5th root of 32? 2. Okay, x to the 12th. How many groups of 5 can you form?
2.
So an x squared comes out. How many are left over?
2.
So an x squared is left underneath my radical. That's still a 5th root there. If I have 8 y's, how many groups of 5 can we form?
1.
So 1 y comes out. How many are left under the radical?
3.
Good. Bless you. Number 2. The square root of 98. Does that come out evenly?
No.
All right. So what do we need to do then? What perfect square goes into 98?
49.
Mm-hmm. So that's 49 times 2. All right, the square root of 49 is, so a 7 comes out, and then under the radical we still have a 2. If you have 9 a's, this is a square root, so how many groups of 2 can we form? Any left over? So an a is still under the radical. If we have 5 b's, how many groups of 2?
2.
Any left over? So 1's left underneath. All right, on the bottom, we had c to the 8. How many groups of 2? 8 divided by 2 is 4. And that came out evenly, so there's none left over, and the radical is gone on the bottom. C, or number 3. So if you have a fraction, you can do the cube root of the top and the bottom. What is the cube root of 64? So I have 4 over the cube root of x squared. Okay, I've got to get that radical off the denominator. This is a cube root, which means I need a group of 3 before I can pull it out. I currently have 2 x's here, so we need, so we'll do one more, so we have the cube root of x that we're going to multiply by on top and bottom. So that gives us 4 cube root of x over the cube root of x cubed. Cube root of x cubed, saying if you have 3 x's, how many groups of 3 can you form? Just one, so a single x. All right, number 4, the 4th root of 32. Does that work out evenly? No. So we need to break it down. Okay, it's a 4th root, so I need something to the 4th power that would divide 32. 16 and 2. So the 4th root of 16 is 2. And then we still have a 2 left underneath. If you have 7 a's, how many groups of 4 can we form? One group of 4 with 3 left over, right? All right, b to the 23rd. So, perfect. If you have b to the 5th, that accounts for 20 of them. So 3 left, b to the 3rd left on the inside. On the bottom, the 4th root of c to the 4th.
C.
So far, so good? So we just have a couple examples left. If I ask you to add or subtract radicals, what has to be the same? Thing under the square root. So I can't break down the square root of 7. All right, what can I break 28 into? Okay. The square root of 4 is 2 times the 2 that's already out there would give me a 4. And then we have my square root of 7. Does everybody understand where I got 4 square root of 7? 63, what would we break that into?
79.
Square root of 9 is 3 times the 4 that's already out there would give us a 12 square root of 7. So now to combine them, you just add the coefficients. So 3 minus 4 plus 12, 11, and the square root of 7 just trails along. Okay, second one, how do we multiply with these? FOIL. When you do that, numbers outside the radicals get multiplied and numbers under get multiplied. So 2 times 4 will give me an 8. Radical 3 times radical 3 is radical 9. Minus 2 times 5 will give me a 10 radical 3. 1 times 4 radical 3 is a 4 radical 3. And 1 times negative 5 is negative 5. The square root of 9 is 3 times my 8 that's there, negative 10 radical 3 and positive 4 radical 3, give me a negative 6 radical 3. Then I have 24 minus 5, 19 minus 6 radical 3. You guys remember doing all of this the past couple days? The last two on here focus strictly on what we did yesterday with getting the radicals off the denominator. So number 3, I have negative 2 over the 5th root of x squared. A 5th root tells me I need 5 of those x's before I can pull it out. I only have 2, so how many more do we need?
3.
So I'm going to multiply by the 5th root of x cubed. Get a negative 2, 5th root of x cubed over the 5th root of x to the 5th, which is just x. And the last one. If there's 2 terms on the bottom, you need the conjugate, which is the exact same thing, but the opposite sign. So it's radical 5 plus 1. We have to distribute. So on the top, radical 3 times radical 5 is radical 15, plus radical 3 times 1 is radical 3. On the bottom, if we FOIL, radical 5 times radical 5 is radical 25. Radical 5 times 1 is radical 5. Negative 1 times radical 5 is negative radical 5. Negative 1 times 1 is negative 1. Positive and negative radical 5 drop, or if you recognize at the beginning they were conjugates, you didn't even have to necessarily multiply them out and show that work. Square root of 25 is 5, minus 1 is 4. Any questions there? So tomorrow, I would like to do a short quiz. It's not very long, it's just the front of a piece of paper, so just a little practice. We have gone over everything on that quiz already, and then if you flip it over, I've given you problems like everything on that quiz. So your assignment is just the back of this notes. Work those 10 problems, and you've got 15 minutes or so right now to do that.